Good morning, everyone. This is Karen Hutton, and I'm welcoming you to the webinar entitled 5 Simple Ways to Bolster Critical Infrastructure Efficiency. I want to thank you for joining this morning. We have just a few housekeeping items to go through before we get started. The audio for this session will be muted, and so if you have any questions or any technical issues during the webinar, please submit them using the question box, which is located in the webinar control panel to the right of your screen. We can respond to any technical issues throughout the webinar, and our speakers will be answering as many content-related questions as the time will allow, including during the session. So certainly type in your questions, and we will get to as many of them as we can. Any ones we can't get to, we will follow up with you with an answer by email. We'll be recording the session and making it available about 48 hours after the webinar ends. So please watch for an email from us with a link to the recording. And if you don't see it, then look in your spam. Hopefully it's not in your spam, or email us at info@nlyte.com to request the link. Now, I'd like to turn this over to our panel of speakers. We have Mark Gatos, our Chief Marketing Officer here at Nlyte, and he is joined by Enzo Greco, Chief Strategy Officer at Nlyte Software, and we're happy to have KG Anand joining us as well from United Technologies, where he is the Global Segment Leader of Data Centers. Gentlemen, thank you for joining us, and I believe we're starting off with you, Enzo.
Good morning, good afternoon, and my sincerest thanks to everyone for your time and attention on today's call. It's certainly a most interesting and timely topic, especially given the focus on data center efficiency, data center optimization. Without question, this is a rapidly evolving market. Data centers are, with all new options from co-location to software as a service, all the consolidation. So this is certainly a very timely topic, and again, we appreciate your time and attention. So if I can just give a very quick point of background to put the rest of the session in context, and then I will ask KG to do the same. So for those who may not already be familiar with Nlyte, we are by far the top provider of management and optimization software for data centers, and most of our customers, as you can see here, we have the benefit of being global. We have the benefit of working with both some of the largest and most demanding kinds of environments and customers, and we also do very well in the smaller and mid-sized segment. And that very broad range of geography, of customers, of industries, certainly is reflected in the maturity of our different product lines. So a little bit of background on us, and then I wanted to hand it off to KG to give a little bit of background on himself and United Technologies, and then I will take it back from KG. KG?
Yeah. Good morning, everybody. I'm KG Anand. I'm the Global Segment Leader at UTC. Before I talk to you about UTC itself, what I would like to do is preface the whole effort here. We are partnering with Nlyte, their data center software capabilities, and bringing our systems and controls monitoring software capabilities to bear, so that you have a complete stack that can be managed from the critical infrastructure side, as well as go into the IT space also. With that said, you may recognize UTC mostly from its aircraft engines, the Pratt & Whitney engines business, and the UTC aerospace systems. They're quite large there. But we also have quite a large presence in data centers and other vertical markets in from the commercial sides of the business. So both Otis as well as climate controls and securities. As you can see, many of our products and solutions in this space you may already be familiar with and you're using. If we can move to the next slide, Enzo. So you see a lot of our brands there below, right from Carrier, HVAC systems, and automated logics, web control, building automation systems. Chubb, which is if you are in the Europe, the Middle East, Asia, Africa areas, you may know of Chubb. Fire detection capabilities from Edwards, fire suppression from Kidde and Marioff, and now, last but not the least, we have access control solutions from both Lenel and Supra. So together with this, we also have a strong analytics capability that is part of the automated logic business that's run out of Atlanta. So as we go along, I'll be here to answer any questions that you have on the critical infrastructure side and how the management of that can be optimized in conjunction with Nlyte's industry-leading data center software. Enzo?
Okay, KG, thank you so much. And I do want to emphasize one point that KG just made, which is we, Nlyte, are a software-only provider, and United Technologies provides almost everything else in the stack within the data center. So one of the reasons that this partnership has been has received the focus and the attention that it has is because it's a very good complementary mix. So I just wanted to emphasize that. So as we saw, the title of this webinar is 5 Simple Ways to Bolster Your Critical Infrastructure Efficiency. And certainly critical infrastructure is one of the most important elements in the data center. It's certainly one of the more expensive elements in the data center to maintain and operate. So efficiency of that is paramount. And there's lots of different ways, of course, that you can do it. We highlighted 5 in this session that we learned firsthand from the market, from customers, from trends in the market. And that's what we wanted to share with you. Now, some of these may appear quite advanced, but they're not, because it's critical to start simple. Start simple, get immediate value, learn from it, and then you can certainly adopt some of the more advanced methods that we will highlight in this session. So if we just take a higher level view of the macro trends, what's really driving some of the key issues in the DCIM and the data center infrastructure management market, which is more of the software side, and the facility market? Well, there's a couple of things, and we'll highlight these as we go in more detail through the presentation. We certainly have the growth of edge, and we'll look at that in more detail. We have co-location providers such as Equinix, Digital Realty, and others, major players in the market coming in with multi-billion-dollar investments, yet they are in a competitive market, and there is a need to focus on absolute optimization as well as differentiation. And the next one is a most interesting one, I think, for all of our customers, which is enterprise data centers have what we call optionality. They're certainly under increased scrutiny, if you will, for their costs and for their optimization. But they also they are part of a much larger fabric, whether it's edge, whether it's co-location. What is really important is to look at all of the different facilities that a customer has as part of a larger computing fabric. As we get into this ever more complex environment, we have to be much more responsive and have much better insight into the overall capacity and management needs of this now suddenly more widespread and complex environment. And then within the data center itself, there's ever more sophistication from the facility side, different kinds of cooling, for example, whether it's precision or free air. Certainly there's advances on the power side, whether it's software-defined power, whether it's in-house or external backup. The IT equipment is becoming ever more commoditized, and with that comes increased scale, especially with systems now incorporating chips like NVIDIA chips, totally different profile in heat and density. So there's a great deal of sophistication. With that sophistication comes new capabilities, but with that also comes a degree of complexity that needs to be managed intelligently to take advantage of all that. So those are the big trends. Those are the macro trends. So if we look then one level below, with those trends, with some of the specific feedback we've received from customers and the market itself, we just wanted to highlight what we find as perhaps the 5 most dominant areas that customers are investing in integrating their DCIM and their BMS systems together. And one of the first is implementing an end-to-end workflow. And the reason that this is so important is we all have experience in how we manage our systems. And traditionally, our DCIM environment and our BMS systems tended to be fiercely independent. Yet, they need to work together much, much better, because when we have this comprehensive workflow, we're able to implement automated failure. We're able to implement automated recovery. So rather than having the building be separate from the applications running within the building, they need to be aware of each other. We can also have one of the biggest ones is being able to manage end-to-end alarms and alerts. In too many cases, we have a whole series of events arising from the facility. How does that affect the application? On the other side, we have any number of events rising from the application, from security to application failure. How should that be reflected in the facility? So having this end-to-end workflow that is able to incorporate these different events and intelligently deal with them is increasingly important. And it's an area of focus in the industry. And I do want to highlight here that the service request can span all functions. So it is, if we look at where the different origination points can be, what triggers off a workflow, for example, it can be the facility. The facility expects that there may be a power issue, and therefore I should alert or even modify the application behavior. If I'm going to take down, for example, an entire application stack because of weekend maintenance, probably don't need to run my facility in the same way. I may have more latitude, for example, in the thermal management within that facility. And that's a very good example of integrating the BMS and the DCIM systems, and we're finding workflow is an excellent way of doing that. So this is the first.
Enzo, this is Mark.
Hi, Mark.
We've got some questions coming in, and I want to tell everybody on the line, we tend to take questions as we go, so feel free to submit your questions as they come in. We'll try and get to them all. But we have a question from Peter here, which is, what processes are most often put into workflows? So I don't know which one of you will take that question, but I just wanted to pose it.
Let me go first, and then KG, I'm sure there's some you can add. The most common that we see is, for example, provisioning. So if I am bringing a new application online, that probably has an implication on the amount of power, on the amount of thermal I may need in a facility. If I'm going to do weekend maintenance, either on the facility or on the application side, both of those systems need to be aware. Those are probably the more dominant, the state of the application, as well as provisioning either hardware or software. Those are really good examples of where we've seen end-to-end workflow used.
KG, you have any thoughts on the facility side? Yeah, so on the facility side, it's mainly the resource utilization planning, how and where the critical infrastructure resources are, the cooling, the power, how that's allocated across the various racks in the white space, so to speak. So the whole planning process, what are the workloads that are, tied to those things, the visibility to that, where the assets are. So tying it all up and understanding on a complete, end-to-end across the stack view of how these resources are used, how they and are there problems? So, are there going to be problems, and preempting some of those things, and if something goes wrong, fault detection and diagnostics part of it, as well as the maintenance part of it. So some of those processes get integrated into this. So those were from the processes part of it, and the workflows that are included on the facilities side from the maintenance and planning part. Those get integrated into the IT side. So you get an end-to-end workflow view of the whole thing.
Okay, thank you, KG, and thank you, Peter, for that question.
Okay, thank you. The next one is analytics. So analytics is a hot topic across all areas, from medicine to self-driving cars, of course. But it has particular validity in the data center. I'm sure you've all seen the same reports, the same vendor announcements that everything in the data center should have an analytics component. And there's a very simple reason for this. Within the data center, modern data centers have a certain scale and complexity that is extremely hard to manage without some kind of cognitive insight. You simply cannot enumerate all the different outcomes. You cannot manage all the different processes because of the very rich environment in which a data center works. Then you have the increased scrutiny and the increased expected optimization of a data center. And again, it's a perfect area for analytics. And what we're finding specific to the topic in this webinar is if we look at the very, very rich inputs that we get from both BMS and DCIM systems, that's a tremendous amount of input, a tremendous amount of different data points. And this is something called multivariate analytics, which means I should incorporate all the different possible endpoints, all the different possible input data, because somewhere in there are going to be really valuable patterns that my analytics system will pick up. And we've always had these input data streams available to us. We typically ignored much of it. So, for example, we only looked at a very small subset of data because it was very hard to manage the tremendous amount of data generated within the data center. But analytics is perfectly suited to manage that very rich input for optimal outcomes. So a couple of key areas. Advanced preventative maintenance. We've always done preventative maintenance within the data center, whether it was our UPS batteries, whether it was in the thermal systems. But now with a much broader set of input, we can be far more accurate. We can be far more proactive in managing that. Advanced predictive failure. Data centers are all about availability. And any additional insight that we have in predicting that failure, in predicting any kind of anomalies, again, that is extremely valuable to the data center, to the operations of the data center. And the point on all of this, whether it's an optimization or security, is that full stack. So being able to incorporate all of the data generated within a data center, whether it's from facilities, whether it's from the applications, perhaps some of these inputs are less valuable than others, but they all should be considered by the analytics system to determine those optimal outcomes. So this is the second, analytics.
So we got another question here, Enzo, and it's sort of related, if you go back, it related to the last sort of comment you made, but it's a question from Bonnie. Does some equipment lend itself better to analytics?
I will give one view of this, and I'm sure KG has a more specific view, especially coming from an equipment provider. There's probably two low-hanging fruit, if you will. One is anything mechanical. anything that has mechanical movement to it is particularly well suited to apply analytics. Those pieces tend to wear out. They tend to have mechanical issues and failures. So anything mechanical, so obviously the thermal systems are one of the key areas of failure in a data center, particularly well suited for analytics. The second would be batteries. So we've always done some kind of predictive failure on batteries because UPSs are only as good as their battery subsystems. So any insight that we have on batteries and how we replace them, what their expected lifetime is, that all goes to the efficiency or the availability of the UPS, which is key. So in summary, anything mechanical and batteries. KG?
Yeah, so I will piggyback my thoughts on this. Enzo is absolutely right. The HVAC systems do lend themselves very well to this. What we've done, we actually are living this experience at our new world headquarters in Palm Beach Gardens in Florida, where our HVAC systems are centrally monitored to see how well they need to be, how much they need to be utilized, or how they should be performing based on how many people are there within the facility. And the same thing can be applied to the data center. At the same time, we are constantly looking we are looking at the health and status of these HVAC systems from a fault detection and diagnostics point of view to predict when a failure can happen and alert people as to, they should be taking care of it right now. That's another one. In addition, I would call this as all perils type of event management. Especially the phenomenon is very sort of localized right now in the U.S., where you have these active shooters going on. So we have a number of recognition techniques. We have in our building, at least, we have even a video monitoring and access control, all these integrated onto a central platform, which is our web control platform, that gives us information on a ready basis as to when people come in, when they go out, who are the people who are allowed into these things, into what spaces. So we can actually avoid situations before they happen. So there are a number of analytics algorithms we've built that run on top of our controls platform to give us this type of information, and it's run out of our building intelligence center. So in a number of areas. In addition, some of these things we feel can also take you into the next, help you go into the next areas of evolving markets like IoT. For example, right, when you are looking at how these assets are performing, you can manage their performance. You can see based on how the utilization is, what degree of changes you need to make in your next generation of products. All those things can also be of benefit to you. So analytics, I feel, can go into a number of areas, from an asset utilization, performance management, and how you can use that to actually make an environment safe, secure, and optimized for, from an operational standpoint.
Thank you, KG. Some very good points. So moving to the next one is, if we look at a building, there's a lot more in the building than just the building itself. There are all the different facilities within the building, the critical facilities, power, thermal, security. But then there's all the IT equipment, and then there's all the soft assets, the software, the virtualization, the user community. And if we're really looking at optimizing the building itself, or we're looking at optimizing the applications, the workloads, which are the most valuable assets within a building, the reason that data centers exist are not for the data center proper, but for the workloads. And if we're looking at optimizing that entire environment, we need to have a holistic view. So one of the areas that the market and customers are focused on is incorporating all of that, from the building to the workloads. How do we use common terminology? How do we have common meaning across these different systems so that we can do proper event management, we can do proper failure management, we can do proper allocation, we can do proper capacity management. And it's really difficult to do so if all of the different assets within the building are separate, whether they're in different systems, whether they use different terminologies, whether they have different metrics. It's really hard to holistically manage that building without taking a building to rack approach. So there's a great deal of value in this area and a great deal of interest and investment by customers, specifically to look at that building holistically, to look at that data center holistically.
Hey, so Enzo, that's great.
Yes.
We have a question from Glenn, and I think it's very sort of timely with what you said. He says, that's functionality. What's business value of holistic management?
The business value is increased availability, because if you have insight from both the applications need the building to be available, and the building itself and all the facilities within the building may be affected or optimized by the application. So first, you certainly have overall optimization and availability. You have ideally reduced costs, because if you know, for example, that a certain set of applications within a data center will not be running, you should reflect that within the building. At the same time, if you have your thermal systems operating in parts of the data center where they don't need to because there's little application load, that should be reflected as well. So, and the third one is just being able to make management decisions, because traditionally in the data center, much of this data has been ignored. So, for example, what is the actual application utilization within a data center? We typically look at utilization, for example, of square footage. But if I knew how the data center was actually used in an application sense, what's the application capacity, I can be far more efficient in how I just manage that facility, how I invest in it, and how I consider options. For example, moving some of that workload, consolidating facilities. So that is the value of holistic management, being able to just manage the facility, but also making the right decisions on it. Okay, Mark?
Okay, great. Thanks for that question, Glenn.
And Mark, who asked that question, Glenn?
Yes.
I just want to make, okay. So next one, and this is very, very much tied into Edge, and especially the growth of Edge, which is by far one of the biggest areas of growth within the data center segment. And what's happening is, as we get an ever more geographically dispersed infrastructure rather than a few very large centralized data centers, now what's happening is we get ever more smaller but geographically dispersed computing facilities. And of course, with that comes the natural fact that these tend to be remote. They tend to be unmanned, which means we need to have remote management. We need to have remote intelligence, because we physically are not able to walk the halls as we would in our enterprise data center, for example. So the growth of Edge has a very interesting requirement being placed on the market, which is automated and remote management in a couple of key areas. Alarm and alert. If I have a remote facility, I certainly will have some alarms and alerts. Some I can ignore, many I can't. But how do I know that being remote? And the alerts could come from the facility, could come from BMS. The alerts could come from the application. The alerts could be security. And traditionally, these systems have been fiercely distinct, which makes them really, really hard to manage remotely. So one of the key elements I need is to have remote holistic alarm and alert management across all the different systems, regardless of where that event arose. And then the second is I need to have some kind of remote visibility. Again, I don't have the luxury of walking the halls. So how is that facility set up? What is the space within the facility? What's the real-time environmentals within there? What's the status of the different systems? I need to have that kind of integration remote. And as I said, this is being accelerated greatly by the growth of edge. And we've all heard about the growth of edge. But one of the, by far, the best examples that I have seen that I'll show on the next slide in why edge is becoming so prevalent is shown here. So here we have
just a second, Enzo, we had a question. Actually, we're getting quite a few questions. I can't get to them all. And so I assure everyone we will get to your questions, whether online or offline. So feel free to keep giving them. So we have a question from Siddhartha. Since we're doing remote management, isn't automation a key element?
Automation is an absolutely key element. And because, again, in many cases, we don't have the luxury of performing the actions ourselves, we necessarily are remote. Automation is also critical because in many cases, that remote facility may be offline as part of a failure. So there needs to be local intelligence either to deal with an event or maybe to recover from an event. So automation is a key part of remote management.
Okay, thanks, Enzo. Thanks, Siddharth, for the question.
So the next one, just one data point on the growth of edge. So huge growth in this market. And we can see, emphasizing what we saw on the prior slide, some of the unique drivers that come from edge. And we already spoke about some of these, remote management and visibility, intelligent operations. It was an interesting question on automation. One of the problems with automation is it assumes you can enumerate all the different cases. And failures can come in many different forms, or events can come in many different forms. So some kind of local intelligence to deal with unexpected events autonomously, if possible, is very important. But I wanted to show on the next slide, again, a perfect example of why edge is becoming so prevalent. And if we look at this on the left, without naming the vendor, this is the network backbone for a noted U.S. Cellular provider. So this is their backbone. So this is their different IP, whether it's live fiber, dark fiber, whatever it may be. This is their backbone. Yet on the right, look at where their users are concentrated. Half of their users are 100 miles or more from the backbone. So if you look at this, the natural growth that, of course, is occurring in the cellular market, in the delivery market, is to build ever more edge data centers. So this is a really good example of why there's growth in edge. This is just one industry. Then look at what's happening in the video market. Look at what's happening in social media, where that's a very data-rich market. That's a very content-rich market. It doesn't make sense to have all of that content centralized. And this is a perfect area for edge. And again, it's called by different terms, but this is why those smaller, geographically dispersed computing centers are growing as quickly as they are. And with that comes the requirements of remote management, tightly integrating the workloads with the facility becoming ever more important. So then the last one, and we've already touched on this one in different ways, is holistic capacity management. And this is an art. It's always an art, especially when you're dealing with just one side of the equation. So it's really hard to deal with capacity if all you're looking at is the facility itself. If you don't have insight into the applications, into the users, into the demand of those different applications, it's really hard to manage the facility optimally. So typically what we do is we oversize the different systems. But of course, that leads to inefficiency, and that leads to lack of optimization, which, as we saw at the very beginning, data centers are under increased scrutiny. So we don't have the luxury of over-provisioning the building. On the other side, in many cases, especially in a dynamic environment where we are moving loads across different environments, we don't have good visibility, for example, on what it costs to run a workload in this data center on this footprint compared to running that workload elsewhere or running that workload in the cloud or in a colo. So having this overall capacity management, this holistic capacity management that incorporates all the different pieces, allows us to just manage the facility, the applications, much better for optimization, for optimal costs, and just, again, making sure that we're making the right decisions with all the right data points. And the last two bullets here are just some examples, automatically reflecting changes in the environment, both in applications as well as the facility. So that is what we have.
I have a question came in from Barry. Thanks, Barry, for the question. How can one achieve optimized capacity management? Sounds like quite a big question, but I'll let you guys give your 2 cents.
That's quite a, you want to take the first crack, KG?
Yeah, I can take a first crack from the critical infrastructure side. So this is something that a number of our customers have also asked us for. How can we really, so we have a set amount of capacity from, if you would, if I can phrase it that way, from a cooling perspective. How do we optimize its use? How do we use it more efficiently? How do we reduce our cost of operations? Because bear in mind that around 35 to 40% of your OPEX is actually driven by the chiller plant that you're using. So is there a better way of optimizing its use? And especially if you are in some of these cooler climates in certain parts of the world, or you're in dry, arid climates in certain other parts of the world, is there a better way of doing this? And again, can you actually turn off the compressor, remotely control and turn off the compressor and just use free air cooling, right? So you filter it, you pump it through the data center and you cool it, and then actually you have dampers that can balance it. So this is one, so we are seeing increasingly a trend towards installing systems and capabilities that then feed into from our controls layer into the DCIM layer. And going back to what Enzo basically said about the edge facility, this becomes much more of a management problem there, because many of these edge facilities are lights out. So how do you really manage those things, right? How do you optimize the capacities that you have? How do you ensure that the right people are entering these facilities? So we've had customers who are customers who are in the technology space, in the education space, and they've asked us. So there's one more regionally oriented, and the other one is more globally oriented. And the West Coast customer was actually talking about how they can centralize the management and actually optimize the operation and use the capacity that they have more intelligently, in a more so that their cost per workload can be managed, it can come down. And so virtualization has given you a lot of benefits, but how do you actually reap those benefits from the critical infrastructure side, making sure that the resources that you have at your disposal are more optimally used? And they have global facilities in Asia as well as EMEA. They want to manage all these things centrally from one location on the West Coast. So they turned to us and asked us, how can we go about doing this? And that's what actually spurred a lot of this discussion with Nlyte for us. So I will leave it to you for the IT side of it, Enzo.
Well, I think it's much of what we've already discussed, which is many systems traditionally were over-provisioned, and I don't think there's the luxury of doing that. I think especially when we have a dynamic environment with options, what kind of continued investment do we have on our enterprise data centers compared to colo, compared to other? There's just as much more focus on cost, on optimization, and accountability. And because of that, we need to be much more accurate in how we actually provision and deal with capacity management intelligently. So those were the 5 areas, and if I can close just one slide on going forward. So what's very important is to take a holistic view of facilities and applications. And many of these we've already spoken about, but what I really like is this concept of a data center aware workload. So if a workload is aware of its environment, how would it behave differently? How could it behave differently? Consider analytics throughout. And again, there's this mantra in the analytics market that I think serves very well here. Which inputs deliver optimal outcomes? And we have a tremendous amount of input data in the data center. And doing analytics right actually shifts a data center from being reactive, which almost everything in a data center is today, from failure to temperature, to being proactive, managing the data center based on expected future state. Consider the different benchmarks of your environment far beyond PUA now that you have much more information. And then don't ignore cloud and edge. It is part of your overall computing fabric. As KG just said, that goes into your capacity, it goes into your costs, it goes into many different areas. So that is our suggestions for 5 areas to focus and some suggestions for going forward. Some context both for KG and myself, and certainly I'll speak for KG in welcoming questions, comments directly, engagement directly. And then we'll close with 2 resources slide. For many of the areas that KG mentioned, these are the resources within United Technologies, everything from automated logic, which has very large presence within the data center, to carrier, to the different environments. And then some resources for Nlyte that deal with DCIM, as we spoke about, that deal with all the different assets you have both within and nearby the data center, so the overall technology asset management environment, and then applying machine learning and some best practices for applying analytics to the data center environment. So with that...
So I'm going to jump in here, Enzo.
Okay.
We're a little over time, but I'd like to take 2 more questions. We've had quite a few more. Like I said, we'll get to everyone's questions. So if we could just take these last 2 questions. One is from Shiva. How much, I think this relates to the analytics slide, how much of historical data is needed for the analytics to make a reasonable prediction of failure? That's sort of up your alley, Enzo. What do you think?
So analytics are a very interesting area here. Historical data is very important to create the initial pattern, to create some of the initial data points, but very quickly that historical data is replaced by real-time data, and which becomes the dominant data source. And we have found that, again, it is based on your cycle and your equipment, but within, let's say, 7 days worth of data, you can get remarkably good insight. The longer your period, so after a month and after several months, you'll get ever more accurate. But we're finding after about a week's worth of data from most systems, and that week reflects the different cycles. It reflects weekends, it reflects Monday mornings and Friday afternoons. You can get a tremendous amount of data after a week with good outcomes.
Okay, thanks for that, Enzo, and thank you for the question, Shiva. And I'm going to end on this is sort of a macro question. I'm going to leave it to both of you to give your thoughts. It's from Aaron. You've promoted a lot of information. I'm sorry. And what is the main driver of BMS and DCIM integration?
I'll give my perspective first, which is a firsthand view of the market and directly from customers. One, and the biggest driver that we're seeing is to achieve ever higher cost targets, ever higher efficiency, availability of both the application and the facility. It is extremely hard to achieve that without incorporating all of the different data points and systems within an environment. So I think it's being forced upon the market for the reasons of efficiency, for the reasons of optimizations, and for the reasons of management. If we are looking at options to the data center, options to workloads, it becomes extremely hard to make those decisions if we don't incorporate all the different systems. So that's a very blunt, first-hand view from the market. Hey, Gino,
so I echo everything that Enzo mentioned. He talked about it's being forced down upon the people on the floor, data center floor. And really, when we've talked to customers and asked them what is the driving force, one of the statements we've heard often is this, that this is now time to do something like this because both IT and facilities are reporting to the same boss, to the say infrastructure director or VP within the organization. And what they are really looking for is, there's a lot of interest from a lot of big companies, a lot of big customers who are looking to take everything from a security, fire safety, HVAC, getting all that integrated and then moving up the stack and also tying that up with the performance of the servers and the applications, so going into the IT layer. So there is, Enzo mentioned about automation, predictive analytics, a lot of these things going to help them actually optimize their environment and let them use the resources they have in terms of people, doing things that are useful in helping advance the business objectives. So, and not doing day-to-day maintenance routine tasks. And so I think automation is probably a very strong word at this point, but if you can, actually get your processes down and working the way you want it, then there is a strong impetus. And then it helps them in a number of areas, and we talked about these 5 use cases. So these 5 use cases then help drive the value for them within the organization.
KG, thank you for that. And Mark, assuming we can close, I'll hand it back to Karen.
Thanks,
okay.
everybody. Thank you, Mark, for moderating the session, and to Enzo and KG for all of this rich and extensive information. Again, thanks everyone for attending. You will be receiving an email with a link to the recording, and we will respond to, as Mark said, we had several questions that went unanswered, and so we will respond by email with those. In fact, Enzo, can you scroll up 2 slides just to show the contact information one more time for yourself and KG? So if anybody would like to note down their email addresses and send them any other additional questions, or you can send them to info@nlyte.com. We look forward to having you visit our website at nlyte.com, as well as joining us on any future Nlyte webinars that are listed on our website. Thank you again, everyone. This concludes our session for today, and appreciate everyone's participation.
Thank you.